on your chat, whatever you've got in. Okay, so question. What does acceleration have to do with catching up? You all said yes. Go ahead, Avrit.
Since we both know that acceleration is positive and they're both going in the same direction, since the police car has a greater acceleration, that means it will inevitably end up going faster, even if it starts at zero, an initial velocity of 0 meters per second, and the car has, we don't know its initial velocity, but it has an initial velocity. But since the police car accelerates at 10 meters per second, you can infer that the police car's velocity keeps getting higher and greater, which at a constant rate, which then means that at one point the police car will catch up to the race car.
Okay, so your explanation was very good. You said a lot of very true things, right? The acceleration is higher. Inevitably, the police car will be going faster than the first car. But that is not the question being asked. Does it ask if eventually the police car will catch up? What does it ask?
It's asking if the police car is gaining ground. And
right now, is it catching up? In this moment, is it gaining ground? Is it closing the space between the police car and the speeding car? Right now, is that happening?
When is this exactly? Is this when the car goes by and the police car still stopped?
Very good question. No, the police car is accelerating right now.
When is it accelerating? After a second? After 10 seconds? After?
Ah, now you're getting it. Lucia, what's the hand? What's up?
When we're saying that an object is moving, we're generally talking over a period of time, because if time is zero, none of our kinematics equations make sense. So if you're asking at time zero, when time is not passing, it wouldn't matter what the acceleration is because the seconds are zero. So it wouldn't matter, but I feel like when we're talking about motion, we assume it's over a period of time. Therefore, we would say that the police car is gaining ground. And I feel like it's implied that if it's gaining ground, it's also over a period of time, not at one specific moment.
Okay, hold on. I'm going to draw you a picture because I'm an amazing artist. Here's my police car. Okay, my police car, the acceleration is 10 meters per second squared. All right, here is my speeding car. He's speeding because he has the speed lines behind him. Okay, so there's my speeding car whose acceleration is 1 meter per second squared. Okay, now that's all that's given, right? Let me throw in a couple other pieces of information. What if right now the speeding car is going 100 meters per second, okay, and at time zero, the police car was at rest before he starts accelerating, right? Okay, so he's going 0, he's going 100, right? So the distance between them is growing, all right? So let's talk about a time period. Let's talk about a time period. After 1 second, okay, 1 second later, how fast would the police car be going?
10 meters
This is a question for anybody.
10 meters per second.
10 meters a second, right? The acceleration is 10 meters per second. That's what 10 meters per second squared means. It means it's going 10 meters a second faster every second. So after 1 second, the police car is going 10 meters per second. Okay? How fast is he going?
101 meters per second.
He's going 101 meters per second. Who's going faster?
The car.
He's going faster. So is the distance between them getting bigger or smaller?
Getting bigger.
Still getting bigger, right? Police car's not gaining ground yet. Let's go another second later. After 2 seconds, he's now going 20 meters per second, right? He gained another 10 meters per second every second. He's now going 102 meters per second. Who's going faster?
The car still. It keeps going until, I think 10. No, I don't know.
Okay, but we've got a period of time here, right?
Yeah.
We have a finite period of time, right? A period of time where we went from 0 to 2 seconds. We could go from 0 to 10 seconds, and the police car is still not gaining ground. Okay, so the point of this question was twofold. Number one, answer the question being asked. The question being asked is the police car gaining ground? The answer to that question is, we don't know. If it's in the first 10 seconds, no, it's not gaining ground. Right? Because it continues to go slower than the speeding car. If it's sometime after that, and Avra did say this when he gave his initial explanation, he said, inevitably, this car will be going faster because of his higher acceleration. He will eventually be going faster. Right? But that's not what the question is being asked. And I know that that's nitpicky. However, there will be questions on the exam on the multiple choice section where you have A, B, C, D, and A, B, and C are all true. They're completely true. You read it, and yes, the forces are balanced. Yes, gravity and buoyant force are exactly the same. All three answers are true, but only one of them actually answers the question that's being asked. Okay? So yes, there is some physics that I wanted to talk about here. Higher acceleration does not mean that you're going faster and that you're catching up. However, at some point it will. The answer to the question, though, is we don't know. We don't know if it's gaining ground. It might be, but it also might not be in this point in time. Does that make sense?
So the better answer wouldn't be that we don't know it. The better answer would be that it depends on what time frame you're talking about after how many seconds have elapsed.
Yep, you should either say we don't know because we don't know their speeds, right? I don't think it even says that the police car was at rest, right? Who says the police car is chasing? I could have been completely wrong in my initial scenario. Maybe the police car is going 100 meters a second and the speeding car is going 30 meters per second, right? Maybe the police car's already done a bunch of acceleration. We don't know, right? So really the point is acceleration, and this is the second point I was trying to get across, is that acceleration doesn't tell us which one's going faster. A high acceleration doesn't mean you're faster. It might mean it eventually, but right now it doesn't mean that. So yes, your answer should be we don't know because we don't know how fast they're going. Yeah.
And the 100 kilometers per or meters per second, I think you put, was that just a guess or did we get
I
that?
totally made that up. Yep.
Oh.
All of the numbers here I totally made up, except I was trying to give an example. Lucia had said, well, you know, shouldn't we be talking about time frames from time A to time B? And so I was giving the example of a time frame, a finite real time frame over which the police car was not catching up, right? So I can create that scenario. And it's just an example. I want to make it clear that just because acceleration is higher, it doesn't mean it's faster. Right? Faster is velocity. We're trying to, it's so hard when we're learning about kinematics for students to separate the ideas of kinematics, of acceleration and velocity. And this is one of those questions that I'm hoping is going to rip those ideas apart to be two completely different things. They're not anywhere near the same. One is telling us speed and one is telling us how our motion is changing. Yes, Arya.
So what would have happened if you had like a negative velocity? Because I mean, both the cars would have been slowing down.
Oh, it could, right? If they both had negative velocities, a positive acceleration could mean that they're slowing down, which means the police car is slowing down faster than the speeding car. Yeah, it could be, right? Other questions? Okay, so I know a lot was there. The two things that I want you to get out of all that. Number one, acceleration doesn't tell you how fast you're going. Okay, so that's the physics concept that was being tested there. We don't know if the police car is catching up because we don't know how fast they're going. Okay, the second thing is that you must answer the question being asked. Okay, all the true physics concepts in the world aren't going to help you if you don't actually answer the question that's being asked at the time. All right, and I'm trying to make a big point of that now so that it's not a big deal later. Okay, awesome. Let's see. 4 is just going to beat that same idea down, so we're not going to do that. 5 is an interesting one, but due to time, we're not going to do that either. You know what? We are gonna talk about free fall. We're gonna do that right now because we have time. We've got 5 minutes, right? 11:45. Okie doke. I got a couple of demos for you and hopefully a video. All right. Let's see. I need to make sure this is far enough back that you can see everything. All right, I've got here, you can see can you see the floor? You can't see the floor. You need to be able to see the floor. All right, I've got here a lovely physics textbook. Okay, this one. And I have a whiteboard marker. Which one is heavier?
The textbook.
This is not a trick question. Yes, the textbook is heavier. Okay? If I drop them, so I'm going to come back here where you can see them, where you can see the ground. If I drop them at the same time, which one's going to hit the ground first?
The marker, because there's less air resistance.
Okay, so maybe the marker, less air resistance. Any other thoughts?
I'm saying the book because I guess the aerodynamic to weight ratio is different. It's higher than that of the marker.
Okay, so weight will probably come into play. What else? Anybody else?
They're going to be accelerating at negative 9.8 meters per second.
All right. Other thoughts? All right, let's go ahead and do it then. I wish you were in class because this is going to be loud. Here we go. 3, 2, 1. What do you think?
I think I was right.
Very similar.
Again. 3, 2, 1.
Same time.
Looks like it.
Pretty close to the same time, right? Isn't the book heavier? Isn't the force of gravity stronger?
No, they both.
So gravity is constant.
Gravity affects them both exactly the same.
Okay, so I heard a couple of comments there. Okay, I made a true statement. The force of gravity is stronger on the book. You can tell when you lift up the book that it is harder to lift up the book. The reason being is that the force of gravity is stronger. Okay, I heard a comment that gravity is constant. Okay, we're not going to say that. The reason being is because if we say gravity is constant, people get confused and say, but the force, okay, yeah, the force is not constant. All right, what you are allowed to say is that, and I heard somebody else say the effect of gravity is the same. All right, the acceleration due to gravity is the same, or the acceleration due to gravity is constant. Okay. Now, somebody brought up the idea of air friction, okay, and I do want to show you this real quick, since I have about 30 seconds. If I drop a piece of paper and a book at the same time, what's going to hit the ground first?
The book?
The book, but that's only because there's air resistance.
Okay.
In a
Okay.
vacuum,
Yeah, and I got a neat way to avoid that. So let me show you. If I drop them like this, obviously, the book hit first. And Avery made the point that, well, because there's air friction on your paper, and because the, you know, and I think it was Sem mentioned earlier the difference in the weight air friction ratio, which yes, is important. Watch this. If I put the piece of paper on top of the book, it's not connected. There's no tape, no sticky tack, no glue. I'm not cheating, right? If I place the piece of paper on top of the book and drop it, what happened?
They fell at the same time.
They fell at exactly the same rate. The paper and the book both fall at exactly the same rate because the acceleration due to gravity is the same. As soon as we take air friction out of play, right, as soon as there isn't the extra air pushing the paper up, the paper is going to fall exactly the same as the book. We don't need a vacuum to show that. You can show that on the moon. I'll share a video with you later about something on the moon and the world's largest vacuum chamber. There's some neat things you can do, but you don't need that. You can see that right there. The paper and the book both fall at the same rate. The only difference is that now there's no air friction because I put it on top of the book. It's not being affected. Questions?
In this sense, in this sense, like what you just experimented, couldn't someone argue that it's because the book is actually creating a vacuum behind it? So like if there's like, for example, in a speeding big truck or so, there's a pocket of air like right behind it, which sort of, I don't know how to explain it, but like, I don't know how to explain it, but like there's a vacuum sort of that can be created, and maybe that vacuum is attaching the piece of paper to the book. So
okay, so I would claim two things there. All right, number one, if you have the physics knowledge to be able to talk about air in that way, air being made up of particles and an object pushing them out of the way and creating a temporary vacuum behind the truck or on top of the book, I think you probably have the correct physics understanding that you're just trying to be a devil's advocate now. Number two, I would argue that the book isn't going fast enough for that really to be an issue, right? And if you look at the issue, it's possible that there's a minor one there, but I'm also fairly certain that if I were on top of a falling book, I could breathe there just fine, that there's not really a vacuum that's big enough there for there to be an absence of air.
Understood. Thank you.
So that would be my response to somebody that was like, no, there's a vacuum there holding it down. Wow. Okay. Well, yeah, that's what I'd go for. Then I might show them the video on the moon or the huge vacuum chamber if they didn't believe it.
Yeah.
All right. Awesome. Thanks, guys. I know it's time to go. That's it for today. You know what? I wish I'll figure out what to do tonight. I don't want to have you guys watch more videos, so I'm not going to post up videos. The next step really is to apply this to the kinematics that we were doing last night. But I'm not going to have you guys watch more videos. You need less screen time. I'll either come up with something else or we'll just forego it tonight. Okay, I'll have something posted or not by 3 o'clock.